Hello, this is Dr. Mike Neves from the School of Computer Science and Mathematics, and this is a brief overview of what we'll be doing in the module Mat-10061 Introduction to Mathematical Modelling. So it's a semester-long module and it's worth 15 credits, which is 150 hours of study time. What the module is about, it's about teaching you methods for modelling and solving real-world problems. So all the techniques and skills that you learn in other modules and within this module, you'll be learning to apply those to solve real-world problems. The structure of the course briefly is as follows. You have in weeks 1 to 11 typical lecture and tutorial style delivery. Everything that we do is supplemented by online resources released in the KLE. And in these weeks, you'll receive assessments through Mobius. You should be familiar with this by now. If not, there's plenty of information to ensure that you get up to speed on the KLE. So assessments will be released on a weekly basis within this period, and you'll get about 4 to 5 questions per release to work on. And this is helping you build up to week 12, where you'll have a class test, which essentially tests your ability to apply theory from those weeks in solving real-world problems. So we're going to meet on 2 days. And in weeks 1 to 11, the plan is as follows. 2 hours worth of lectures and a 2-hour tutorial taking place in a computer lab, where you'll get the opportunity to ask questions to me on Mobius questions and assessments and examples which are in the notes and anything else related to the notes. In week 12, we'll have a revision session prior to a class test, which will take place in the final session of the semester. There is the timetable put on the KLE version of the module, but I urge you to check regularly your timetable on the system. As you know, this can change. This is a sort of overview of what we'll do. We'll start with a short look at the modelling cycle, which gives us a motivation to what we'll do in the remaining weeks. Then we'll move on to dimensional analysis, which is an important tool for building models which apply to real-world scenarios and help us to check if what we're building is correct. Then we'll start with the usual tools by which real-world mathematics is based on. So we'll use differential equations in weeks 2 and 3 to start modelling real-world scenarios. This is an important piece of theory which helps us to look at the solutions to those differential equations, those models, and determine which ones are physically realistic for the purposes that we've built the model for. And it allows you to get quite a lot of information from your models without actually solving the models. So equilibrium stability of systems is fairly important. Then we'll move on to looking at systems of ordinary differential equations, which help us to describe how things couple in reality, how different physical phenomena can couple and influence each other. Then we jump to the analysis of finite difference equations. Again, this is another super important method for modelling problems where the timescales between individual changes in the system can be large. After this, we're headed to kinematics, which is the theory that uses vectors to describe how objects move in three-dimensional space, and these are the basic ingredients to the theory on the dynamics of particles, where we'll also try to look at projectile motion. Then in week 12, we'll have a revision session and the class test. Okay, so again, once more, you'll have assessments through Mobius, that is weekly assignments, and the class test in week 12. You actually have to be registered to Mobius or the Mobius class homepage for this module, and there is a link on the KLE. tell you more about this in a second. You click this link and for the first time it will automatically register you to the class. So there's a content area for Mobius on the KLE. Again, this is just a brief breakdown of what's going on here. We have continuous assessments in weeks 1 to 11. I'll notify you when they'll appear. I'll also give you a sort of kick when things are closing down, i.e. when we're approaching deadlines, so that you can keep an eye on things. But Mobius also has the facility to tell you when these things are open and when they close. Again, each batch that we release contains about 4 to 5 questions each week. Some of them will be supplemented with practice questions to help you build confidence in what you're doing. Some of them won't be. And this will be the part where it tests your ability to do things without having a practice first time round. There's the class test in week 12, and this is where 60% of your score, your final score. And again, this tests your knowledge on the theory that we cover in the course. I'm going to release more details on this nearer the time. It's important to think about what you're doing in every module in terms of employability skills, and some key transferable skills are listed here. So many of you will enter the graduate job market and be given problems or jobs where you'll be needed to interpret the information given to you and try to use your skills to synthesize mathematical models and processes which help to describe what is in the data or what information you've been given. There's also an accuracy aspect, because you have to develop an accurate model to determine what is, or accurately predict behavior within that information or data you've been given. And there is an accuracy aspect in creating the solution and applying this in a predictive sense. And that's what we'll look at also in the course. There's also an accuracy element concerning coding. So we'll use 2 types of coding in this module. One is the Python coding that will be used in Jupyter. I'll tell you about this in a second. The other is Mobius requires analytical answers and numerical answers to be typed in using a coding language that's quite familiar in other systems like Maple, Mathematica, GeoGebra, etc. And also in Python as well. Here, the final transferable skill concerns your ability to organize yourself to ensure that you're able to keep up with the weekly release Mobius assignments. And this is very important. It's realistic, but you have to organize yourself. There's plenty of time to do assessments, so there's no reason really for not being able to complete this within the time that these assessments are open for. Another thing, going back to the aspect of a coding language, we're required to be accurate in the graduate job market. Some of you will seek maybe jobs within data science, finance, engineering, and you might be required to do some coding, typing formulae, etc. there. In those scenarios, if you get something wrong, it's not possible to turn around and say, oh, well, I had the correct method. Because those kind of mistakes in that software, which are then employed, end up in costing people jobs, end up costing people possibly lives. And there are plenty of examples within the world today where this is happening. Therefore, there's no room for error in using such systems. And there's no room for error in this course for making silly mistakes in Mobius when you enter your answers and then trying to say, well, I had the correct answer. We have to be 100% accurate when we use this system. We have to learn how to use it accurately and learn how to code the answers accurately. Okay? So this is a bit about Mobius. You'll see that it's giving a question. This is typical of what we might see on the course. You have some information here concerning a model. Actually, the equation's been given to you. You've been given some data here, and you've been asked to solve this model. Here are the parts that we need to attempt. And there's an answer box. You solve the question and you enter your answers in these boxes. The answers require you to use coding language or coding syntax. And again, you should be 100% comfortable in using this syntax before you start putting in answers into Mobius. So here, let's assume I'm lazy and I don't do anything. So I leave the answer boxes empty and I submit the score. So as we go through, just keep an eye on these numbers here that you see. So I'm going to submit without entering an answer. And what happens is automatically I'll be given my feedback on my attempt. In this case, I put no answers in and the feedback is telling me my response was no answer. And then it gives me a correct response, which tells me essentially what I need to work towards if I'm to solve this problem. And in this case, it's a good tactic is not to dive straight into another attempt on Mobius, because the number of attempts that you have can affect your score. Information is given in the KLE and on the module about this. But this essentially gives me something to work to so I can practice what I'm doing in this question, get it right, and then I go back in and have another attempt. So on my second attempt, you'll notice that now the numbers have changed. Again, I'm being asked similar questions. It's asking me to input the answer using the syntax typically used by many packages and even graphic calculators. So you'll recognize the way this has been typed in. These are my solutions for this question. These are sort of things I'll developed in the background on pen and paper or used Mobius. Used Jupyter to help me develop the solution too. I hit grade and then I get new feedback on my answers. So there's my response and you'll see that it's been marked correct with a green tick. There's no comment to give on top of this because the correct response matches the responses I've given, so there's no need to duplicate the correct response there as it had in the case when we got this wrong. So this is how it works. Okay. Now, the materials on the KLE, we've got the lectures stored in the lectures folder. All right, so just a quick word about the materials on the KLE. So hopefully you're able to navigate to this page within the KLE. So this is your module page for Mat-10061. So this is in fact the content page, the top of it, what I'm showing you. So if you scroll down, what you'll see are the usual module information tab and an assessment briefs tab. So you can go here if you want to find out more about the module and about the lecturer, me. So this is standard stuff you've seen before. If you want to find out about the assessments, which is the continuous assessments from weeks 1 to 11 and the class test in week 12, please just click this chevron, it'll unfold and then you can see the assessment briefs for those assessment components. If you go further down, then what you will also see are, at this point in time, 4 tabs. The first is one called Jupyter. So if you just click these things, they unfold. The second one is related to Mobius assessments, and this is where you'll go to do everything you need to do within Mobius so that you can get marks that contribute towards your final score. And then what I've done is I've put the content down for week 1. Right, so if I go to this first one, Jupyter, if I just unfold this, and then what I see is a list of items which introduces you to Jupyter and tells you how to get there. So please have a look inside there right? There is the Jupyter Hub that you'll use throughout the entire module. And this Jupyter Hub allows you to do coding in Python through notebooks. I've provided a tutorial on how to get to grips with the basics of Jupyter. And I would also like you to try and work through these Jupyter notebooks, which you can upload to the hub and go through reading them and trying the exercises there. Please do this because it's important that you learn additional skills to support what you can do mathematically and verify what you do with pen and paper calculations. So these are all super important. This last one, this is just a notebook that contains several basic commands which you can use in the future if you forget certain commands to copy and paste into your notebooks that you're creating at that time. Okay, so make sure you go through all of this. Then what you have is the next tab, which is the Mobius Assessments tab. Please unfold this and please go through everything that you need to do in order to be able to use Mobius through this link. Okay, so this means clicking these items here and reading and following very carefully everything that's underneath here. There's video tutorials, there's a Mobius FAQ, it tells you how to use the Mobius system. And this is a recap of the assessment brief for the continuous assessment in week 11, so that's that one. Then, only then, once you've been through all of this and you're very happy with how things are going to work with Mobius, you'll go into this link and you can start using the system and you can start going through the assessments that are put up there. Finally, what else I've put on the page includes the first week's content. What I suggest you do is you try and take a look at this before the lecture when we meet. What will happen is I will update as we go from topic to topic. I'll update the content area by putting additional topics down here or tabs that correspond to those topics. Okay, so what happens is you go into these things here, you just unfold them and then you start working through the material as guided by the numerical order of the tabs inside these tabs. Right, now just a disclaimer about content that you'll see inside here. Well, I have videos inside these tabs and these videos may refer at times to a different module code. Don't worry about it, you're on the right course, okay, so you're on Mat-10061. I simply have changed the title and the code for this module in recent years. Okay, so that's more or less it about the materials on the case. Pick up this for future use if you're interested in modelling problems in mechanics. This is a fantastic book. Getting used to modelling with differential equations, this is also an excellent book. These are not compulsory, but just keep these in mind. What's contained in the course is enough to do what we need to do for the assessments. Okay, thanks for your attention. See you soon.